Hello friends, welcome to my YouTube channel Spiral Learning. So this is my third lecture on the chapter 11 Electricity, which is taken from in CBSE NCERT class 10 syllabus. So in this chapter, the topic that we are going to discuss today, first one is factors on which resistance of a conductor depends. Second, expression of resistance. Third, expression of resistivity or specific resistance. Then definition of specific resistance or resistivity, CGS and SI unit of resistivity, and specific resistance, and one numerical example on the calculation of resistivity. Let's start. So the factors on which resistance of a conductor depends. So first of all, we should keep in mind that we are considering the dependence of resistance at constant temperature because the temperature change will impact the change of the resistance. So our study is at constant temperature. Okay, so when the temperature is constant, we are studying on which factors resistance of a conductor depends. So we will start with the line at constant temperature. At constant temperature, resistance of a conductor depends on the following factors. Okay, so the line is very important. We should write at constant temperature. Okay, because when the temperature is variable, the study is meaningless. Okay, so we should keep in mind that when the temperature is constant, then the study is applicable. So first of all, for the realization, we should draw a conductor. We are considering a cylindrical conductor. It is not obvious that the conductor is always in cylindrical shape, but most of the case the electrical wires or the conductors are in cylindrical shape. So we are considering a conductor PQ. Okay, so suppose the length of the conductor is L and area of cross section is A. Okay, so at constant temperature, resistance of a conductor depends on the following factors. In previous lecture, we know resistance is represented by the letter capital R. So first one, we can write resistance of a conductor depends on its length. Okay, but how? There is a question, how? So from experimental observation, we observe that resistance of a conductor depends proportionally with its length or directly proportional with its length. It is R proportional to N. But when area of cross section A, that is area of cross section is constant. Okay. Second, resistance of a conductor depends on its area of cross section as length, can write it as R proportional to 1 by A. That is, area of cross section is inversely proportional. Resistance of a conductor is inversely proportional to the area of cross section. Okay. Where or when length L equal to length of the conductor is constant. Okay. So what we learned that resistance of a conductor depends on two factors. First one is the length, second one is the area of cross section. When area of cross section is constant, then resistance of the conductor is proportional to its length. Okay. Again, when length of the conductor is constant, then resistance of that conductor is proportional to the area of cross section. So these are the main dependence. And another one is there. This is third one. That is resistance of a conductor depends on the nature of what? Nature of the material of the conductor. What does it mean? That is, if the conductor is a copper wire, then its resistance will differ when the material is a iron or when the material is steel. Okay. For different material or the nature of the material, the resistance will be different. Okay. So practically there are three components on which resistance of a conductor is depends. Obviously, at constant temperature, the factors are length, then area of cross section, and then material of the conductor. Okay. So these are the three factors on which resistance of a conductor depends. Now we are explain the next topic. Expression of resistance. So in the previous slide we draw a conductor like this. PQ is a conductor, its length is L, area of cross section is A. Okay, so we observe that resistance are proportional to L and inversely proportional to A when temperature is constant. Okay, this is our previous slide explanation. Okay, so we observe that this is a proportional relation. So for converting this proportional relation into an equal sign, we need a constant, and here the constant is rho. It's called rho, L by A. So first of all, we should write here rho, where rho equal to constant of proportionality. Okay, now the expression becomes R equal to rho L by A. This is the mathematical expression of resistance. Okay, now in our diagram we show a conductor PQ of length L, area of cross section L. Area of cross section is indicated with letter capital A. So since the conductor is a cylindrical one, so it has a radius, and suppose the radius is R, and the shape of this cross sectional area is circular, or it's a circle we can consider. Now A, we can write A equal to pi R square. So if we put the value of A in the above equation, so we get another expression of resistance. Suppose this is equation 1. So from equation 1 we have R equal to rho L by pi R square. This is another expression of resistance. Basically all are same, but they are different their appearance. Now we again consider that the area of cross section of the wire in terms of its diameter. Suppose the diameter is D. Okay, so area of cross section can be expressed as pi D by 2 whole square, because the relation between, as you know, the relation between diameter and resistance, radius equal to diameter divided by 2. Here radius is R, diameter is D, so we are writing in place of R D by 2. So pi d square by 4. Now from equation 1 we have r equal to rho L by pi d square by 4, and then 4 rho L by pi t square. So this is another expression, so we can simply write r equal to 4 rho L by pi t square. This is another expression of resistance. These are the three expression of resistance. All are necessary to remember because for solving the different kinds of numerical example, all these formulas or mathematical expression are important. Okay, so all these three equations are basically same. We are replacing the area of cross section first in terms of radius, second in terms of diameter. Okay, in all these three expression, area of cross section is same, but their appearance is different because first we are expressing the resistance in terms of area of cross section. Second, area of cross section is represented in terms of radius, and in the third expression, area of cross section is represented with the help of diameter. That's all. These are the three forms of the expression of resistance. Now the next one, expression of resistivity or specific resistance. In the last discussion, that is in the previous slide, we get an expression R equal to rho L by A. So here rho is a constant of proportionality. First of all, it is a constant of proportionality and it is known as specific resistance or resistivity. Okay, this is where rho equal to, it's a constant of proportionality obviously, but it has a name and the name is resistivity or specific resistance. Resistivity or specific resistance. So after cross multiplication of the above expression, we can write in this manner. Now we are interested to find out the value of rho, so we are writing rho equal to R A divided by L. So this is the expression of resistivity, R A by L. Like previous expression, we can also replace area of cross section in terms of radius and in terms of diameter. So if A equal to pi r square, then rho equal to r, in place of A you can write pi r square divided by L. This is another form, the expression of resistivity, and suppose this is equation number 2, and again if A equal to pi d square by 4, that is in our question when the area of cross section is expressed with the help of the diameter. So in this case we can write it in this manner. Okay, pi d square by 4l. These are the three form the expression of resistivity. Okay, so for defining the resistivity we can use any one of them. So in the next slide we will explain the definition of the resistivity using equation 1. Definition of specific resistance or resistivity. So in previous slide we see that rho equal to R A by L. Okay, so for defining resistivity or specific resistance, we can assume a conductor if A equal to 1, that is a conductor of unit cross sectional area and unit length A equal to 1, then rho equal to R. So we can define resistivity as the resistance the resistance of a conductor of unit length and unit cross sectional area area is called its resistivity. Okay, the resistance of a conductor of unit length and unit cross sectional area is called its resistivity, or is called resistivity. Okay, so now we can define easily with the help of this expression rho equal to RA by L, the definition of the resistivity. Okay, so simply we will assume that we are considering a conductor of unit length and unit cross sectional area. So in our previous slide we show a conductor PQ. Okay, PQ. So if we are considering a conductor PQ L equal to 1, it's maybe 1 meter, 1 centimeter, whatever it may be, should be unit. A equal to 1 meter square, then its R equal to its rho, that is its resistance gives us the measure of its resistivity. Now the units of resistivity. So we know rho equal to R A by L. Okay. Now first we are considering the SI unit. SI unit of rho, that is resistivity. Okay, so SI unit of resistivity equal to, first of all we should write the SI unit of resistance, which is ohm, then the SI unit of area of cross section, which is meter square, that is meter into meter, that is meter square, and the SI unit of length, it is also meter. So here it's meter square, so we can cancel 1 meter ohm, here ohm dot meter into meter, length into breadth, here is another meter, so meter can cancel. Now the unit becomes ohm hyphen or dot meter, or we can express ohm by its symbol like this, then we can write ohm meter. Both are correct. Okay, this is also correct, this is also no problem. Whatever you should write in the examination paper. Now the CGS unit of rho or resistivity. Okay, it is the practical unit also, so we are writing resistance as ohm, but area of cross section in terms of centimeter square or centimeter into centimeter, that is length into breadth, since it is area, and the length in terms of centimeter, so centimeter cancel. Now it's ohm centimeter, or in terms of symbol ohm centimeter. This is also correct, this is also correct. These are the two examples of resistance of resistivity. Okay, so now we are considering a numerical on the basis of the formula that we discussed so far. So we are interested to find out the resistivity of a conductor. Okay, obviously at a certain temperature or a constant temperature. So let us consider a numerical. So a conductor we are considering a conductor. Okay, the length the conductor is given as 1 meter. Okay, 1 meter. Resistance is given as 26 ohm. Okay, and at temperature is constant. At our previous discussion, temperature at 20 degree centigrade temperature, it is constant. Okay, so it is necessary to mention that the temperature is fixed at 20 degrees centigrade, because when the temperature will be increased, the resistance will also change. Okay, so it's necessary to indicate its temperature. Okay, so the diameter D is the diameter. Okay, diameter is also given. D is given as 0.3 millimeter. Okay, so now our task is to calculate the value of rho. So our task is to calculation of the value of rho, obviously at 20 degrees centigrade. Temperature is constant. So it's quite simple. So we are using the formula where diameter is given. Okay, so let's see the previous formula where diameter is included. So this is the equation. This is the equation number 3 where diameter is given. So the formula is rho equal to r pi d square divided by 4l. Okay, d is given, pi is 3.14. Okay, so all these things are given. So let's start our calculation. Okay, the formula equal to rho equal to r pi d square divided by 4l. Okay, so according to question, resistance is what? It's simply 26 ohm. Pi is 3. You can write it 3.14. So D is in millimeter. So we should convert it into meter. So 0.3 into 10 to the power minus 3. Okay, for converting it into meter, or we can write it 3 into 10 to the power minus 4 meter. Okay, so 0.3, that is 3 by 10. So we can express it in terms of indices like 3 into 10 to the power minus 4. Okay, so we are writing 3 into 10 to the power minus 4, then whole square 4. What is the value of rho? It's 1 meter. So we should convert the millimeter into meter because we are considering the value in SI system. So now you can calculate the value. So after calculation we will get a suitable value, and the value is 1.84 10 to the power minus 6 ohm meter, which is the SI unit. So this is the value of the resistivity of the conductor, whose resistance is 26 ohm. Okay, length is 1 meter and diameter is 0.3 millimeter, and we are converting the diameter in meter, that is in SI unit. So the resistivity of the conductor is 1.84 into 10 to the power minus 6 ohm meter, obviously at 20 degree centigrade. So this is the answer. So thanks for watching the video. In the next lecture, the series combination of resistance will be discussed. Thanks once again.